All right, let's do some random and systematic errors. There's those are the two types of error. Now, before we jump into it, we need to understand the difference between a repeatable experiment and a reproducible experiment. So, a repeatable experiment is when you can reproduce your own value. Okay, but a reproducible experiment is when other people can reproduce your value. In the scientific community, it doesn't. Your experiment doesn't really count if it's not reproducible, even if you can do it. So that's why we peer review our papers, and that's why other people try to reproduce different experiments. So this is the real magic one. That is a difference that the syllabus says you need to know. So a random error is something that is where you'll have measurements that are too high or too low, that are typically maybe an observational one with like reading a burette or a color change. So fluctuations or insufficient data. But systematic errors are things that were problems with the system. Well, most often it's a personal problem. It's something's going on with the experimenter. So the classic example of the systematic error is going to be the graduated cylinder, and you were supposed to read it from eye level. Although I've seen many students do this. They read it from a little bit angled up because they're standing up, and it angles down. So the way you see it, you're actually going to read it a little bit low, or if you're too low, you're going to read it a little too high. Okay, so that is the classic example of the angle of observation. A great example of a random error is kind of like if you look at a balance, you notice how sometimes it will read 0.01, right? Or it will fluctuate back and forth. That is a good example of that. Sometimes it just the air circulation or something like that is doing that. That's a random error. So the way we try to take care of these, or we're at least conscious of these, is if you draw a sketch of random error and systematic, and this is random, and then this is systematic. If you're measuring a quantity 5 times under the same conditions, if there are only random errors, then the five measure values will be spread about the true values. Some will be too high, others will be too low. So let's just say our true value is somewhere right here. And for consistent, let's have the same one. So our true value is supposed to be right there. Well, that random error is going to be somewhere dancing around there. Okay? Something like that. Hopefully it's close to the true value. Now, a systematic error is going to probably dance somewhere around here. It will still dance because there is always systematic error. So, or you will get something that's consistently too high. Okay? So you should be able to see the difference. This is where the experiment needs to be fixed. Something's going wrong that's making you get too low or too high. The way we avoid this one is that we run more trials, we average them out, and they should be able to fix themselves. So if you want to repeat your trials, let's see, this is why we have many trials or many groups of numbers. That way we find the average of them, and then you'll have to fix the experiment. Something is going on. All right. So now when the final uncertainty arising from random errors is calculated, this can be compared with the experimental error that we did before in the previous video. Remember, we calculated experimental error. And we've also figured out how to find out the final uncertainty by propagating, right? So let's combine those two together. If the experimental error is larger than the total uncertainty, then the random error alone cannot explain the discrepancy, and systematic errors must be involved. So again, let's do a quick sketch. And I'm going to take, let's just say I've got a really great experiment, and this is the data that I collect. What your graphing is going to have is it's going to have some error bars right here. It's going to show all that uncertainty right here. What it's saying is that you're sure about this point, and then your uncertainty is being included right here. All right. So you'll get a bunch of these. Now you can't have X and Y uncertainties, and that's really helpful, but you should always have these little error bars. Now let's say the experimental trend is this one right here. Goes straight on through. Whoops, I kind of missed that one. That's the experimental trend. This is why we have computers do that for us. Well, if your let's say that this is the true value right here, and it's all within the error bars, that it's within the final uncertainty, then random error is the cause. But if it is all below, kind of like that, then systematic error is the cause. Okay? So this is the ideal situation where you're trying to get to, and this is where what you want your data to look like. And that would be a perfect score on your IA. So that's what you're looking for. All right. So that'll be it for random and systematic error. I'll catch you again on graphical techniques.